More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at home. Real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at home is right for your child, visit mathnasium.com/at-home. Mathnasium at home, changing lives through math.
Hello everyone, and welcome back to the Mathnasium Schoolhouse. I am John, the AVP of Education and Training for Mathnasium, and I cannot believe that this is the 6th mental math session that I've done with you all, which is really cool to think about. And I've done a lot more than that, and Mathnasium has done a ton of these, and I hope you've enjoyed them all. So if you've been with me for all of these, welcome back. If you're new, definitely welcome to the channel. I hope that you find this fun and interesting and exciting. As always, the only thing that I ask is that you work really hard. And just because this is the 6th one that we've done, don't feel like you are totally going to be lost. We'll always take it slow, and I'll give you plenty of opportunity to practice. So even though this is a mental math session, as a reminder, or if you're new, you can use pencil and paper. I will be writing things down that you could copy down, and just use those for notes later. And I hope that you rewatch this and practice the things that we talked about today. So what do I have in store for you all? I have a whole bunch of stuff. I have addition, subtraction, multiplication, maybe do a couple percent problems and have fun while doing that. And a lot of these problems that we're going to talk about today, when you come to Mathnasium, if you're not a Mathnasium student, they're part of kind of what we call our workout books. And this is a place in the workout books where you got to have fun and explore math and do some mental math stuff like we're going to do today. So I hope that you enjoy this lesson, and I hope that you check Mathnasium out. Can do it at home in the exact same way that we're doing it today, and then we put together a really great plan for you to get better and practice what you need to practice. So I hope you have your piece of paper, a pencil, and of course your brain. Okay. So with all of that said, I want to kick it off with something that, if you were with me yesterday, I left off with, and if you're new, we'll start from the top. So let's take a look at a problem like this. So 19 times 21. And we've talked a lot about the different ways that you can look at multiplication problems and friendly numbers and things that might be a little bit easier to multiply in your head. And then you just have to maybe add or subtract something after you've multiplied. And that's what I want you to do here. And what I want you to when you look at this, I want you to think that both of these are very close to what number are both of these very close to? And you can leave it in the comments and introduce yourself and all those really cool things. Both of these are close to the number 20. Okay. Now, I want to multiply two numbers together, and I found 20 because they're both very close to 20, and 20 happens to be right in the middle. So I want to multiply 20 times 20 here, but it's not as simple as, well, both of them are one away from 20, so I can just make 19 20 and make 21 20 and multiply them, and I'm okay. It's not quite that easy when you're multiplying. So, but I'm going to multiply 20 times 20 because hopefully 20 times 20 is not so bad. It's something that you can multiply in your head. They're friendly numbers. And so I want you to think of that first, and that's 400. Okay. But that's not quite the right answer. And when you apply this technique, what you have to ask yourself is how far apart are 19 and 20? They're one apart. And 21 and 20 are also one apart. I take that and multiply times itself, and I have to subtract that from this. So 1 times 1 is 1. I have to subtract 1 from 400, and I get 399. So when you have two numbers that are evenly spaced apart from some really friendly number in the middle, you can do this. So you can try that out. Yesterday, we talked about how to multiply something by 20. So maybe you decided that you wanted to do it that way, which works too. Multiplying by 20, you can take that number and either double it and add a 0, or multiply times 10 and then double it. If you did that, you get 380. I just needed to add one more 19 because I needed 21 19s, not 20. Either way. But this is practicing that technique that we ended with yesterday. Okay. Let's do another. So I'm going to give you a second just to think about it. Okay. So remember, the first thing we're going to look for here is there a nice number that's kind of easy for us to multiply that happens to be halfway in between those two numbers? And there is. Hopefully you saw that 60 is halfway between 58 and 62. So our next step is to multiply 60 times 60. Now this one's a little bit bigger, but multiplying multiples of 10 together, it's not so bad. What's 6 times 6? You get 36. And I just have to add in these zeros. I get 3,600. Okay. But remember a moment ago I mentioned that it's not quite as easy as, well, I just make, because they're both close to 60, I just make them both 60 and multiply. I have to adjust my answer. So my next step is, how far apart are 58 and 60? Or 62 and 60. They're both 2 apart, so I have to multiply 2 times 2, and I need to subtract that from 3,600, and you get 3,596. So there you go. If you want to create your own problems, I'll give you a worksheet after we get done, and you can practice. If you're a parent, you can make up problems that are just like this, and one's number that's a little bit less than a multiple of 10 and one that's a little bit bigger than a multiple of 10 that are both evenly spaced apart, and have your child practice. These are the things that as they continue to practice them, they start to look for these things. And it doesn't always happen, but I want you all to start looking for these things first, because your brain is a powerful thing. And when you start looking at stuff this way, then it helps with all of your math and your problem solving and that. Okay. So if you're not super comfortable with multiplication, let's take a look at this addition problem. And for some of you that are, really awesome with addition, you could just add them up. But remember, we're always looking for little things to help us kind of do these things mentally. And what I want you to look for are ways that I can group these numbers together to help us add them more quickly. So what if I put these two together and these two together? And I thought of this one as, okay, in thinking in my head, what's 2 plus 14, which is 16? And what's 6 plus 10? It's also 16. So I have two 16s, which is 32. So you might be thinking, I added 2 plus 6 and I get 8, and I added 10 more, I get 18, I added 14 more, and I get 32. And you could do that. But sometimes you're presented with problems that it might make sense to kind of pair them up. And you'll also notice that, what do you notice about 2, 6, 10, and 14? They're all 4 apart. Okay, so there might be a little bit of a thing there to pay attention to. Might be a little bit of a thing to keep in the back of your mind that if they're all evenly spaced apart, there might be kind of a cool little shortcut here, and that is true here. All right, let's take a look at another. So I've added a couple things. So now if you're going to try to add them just from left to right, well, now you have to add 6 things together instead of 4. But maybe try to do what we just did and see if that helps you. And if you're a little bit older and you've been practicing writing your factors, sometimes you use what's called the rainbow method. So these little lines here, they start to make sense because you connect things that are meant to go together. Well, it's the same idea here. I want to take and pair them up because what do all those pairs equal? Even though they're different numbers, just like the last one, they all equal 16. But how many pairs of 16 do I have now? I have 3 of them. So my final answer, I switch back. My final answer is 48. So when you're thinking about this mentally, if you practice your addition and you might be able to do 3 plus 5 plus 7 plus 9 plus 11 plus 13 in your head really quickly. But I can make these numbers really big, and if you start looking for pairs that might add up to the same thing, then it helps you. So when you look at that, you can think, okay, 16, 16, 16, that's 48. Which is faster than adding them from left to right. And as you get older, you'll learn a really cool formula that will help you calculate that fast. And maybe one of these days we'll talk about it. But just like the last one, notice they're all 2 apart. 3, 5, 7, 9, 11, 13, they're odd numbers. And they're all 2 apart, and it's something just to notice. Okay. Now, I made it even bigger. Now the numbers are small, but I gave you more of them. So let's see what you do. So you could 1 plus 2, then add 3, then add 4, then add 5. And there's a lot of stuff to add up. I'm going to put 2 things up here. And there's actually 2 different ways that people usually think about this problem. They either think of it that way, or you think of it that way. Okay. Now most of the time, you try to make 10s or multiples of 10 because those are easy to work with. But if I pair the numbers that I see in red, what am I making pairs of? I'm making pairs of 11. So I have a pair of 11, another pair of 11, another pair of 11, that. If you work this out, you get 55. If you do it the blue way, you get pairs of 10. So I have 1 pair of 10, 2 pairs of 10, 3 pairs of 10, 4 pairs of 10. I have this 10 that's out here, that's 5 10s. And then you have to remember that there's this 5 in the middle that didn't get paired with anything. So I have 5 10s and another 5, and I get 55 that way. So which way is your favorite? I know I have my favorite way of looking at that. And what's really cool about this, and something for you to practice later, is that in the same way we did that, if I were to ask you to add all the numbers up from 1 to 100, guess what? I'm running out of room, but guess what? That's 100 there. The same way you did all of these numbers from 1 to 10, you can do all the numbers from 1 to 100 the exact same way. It's just you have different pairs and more of them. So I'll let you try that one on your own. Okay? But this works for that as well. Awesome. Okay, let's like I said, I have a lot of different stuff for you to do today. Let's talk about subtraction. Okay. Now, like we talk about sometimes when we do the mental math lessons, you still need to be able to write it down this way because it's important for school, it's important to your teacher. And if you right now you have to think about it that way, that's okay. But what's important to me is that you keep practicing and that you're confident because you're really smart, that you look at that problem and you think, I can do that mentally, because you can. Now, when you come to Mathnasium, we talk about subtraction in a couple different ways. And one way is how far apart are those two numbers, and the other way is how much is left. Okay? Now, you may look at subtraction and think that I don't want to add to subtract, but sometimes you can kind of count up, and that helps. So when I look at this, one way to think about it is how far up is it from 197 to 200? So if I start at 197 and I go up to 200, how far up do I have to go to get to that 100? -3. Okay. Now my next question for you is, how far up is it from 200? Because I went up from 197 to 200. Now how far up is it from 200 to 500? It's 300. And I add those two things together. Now that's not the only way that you can think about it mentally, but it works really, really well. Okay. And it helps you take things like that and subtract them. But it's a little bit different because you're used to kind of taking away. But if you think about it moving up, starting at the smaller number, how far up is it to the next kind of friendly number, that 100, and then how far up is it from that 100 to the next, from 200 to 500. Now there's other ways to think about it. You could have said, and we've talked about this before too, that 197 is really close to 200. And then you just have to ask yourself, did I subtract too much or not enough? If I subtract 200, I subtracted too much. So I just add 3 to my answer. 500 minus 200 plus 3 because they're 3 apart. Okay, awesome. Let's take a look at that one. I'll give you a chance to practice. It's very similar. I'm going to write this one in a little bit of a different way. So I'm going to start here. $498 is really close to what number? And how far apart are they? How much did I have to add or count up to get there? 2. Well, I want to get up to 700. So then my question is, how far do I have to go to get from 500 to 700? Well, so if I have 500s and I need to get to 700s, that's 200s. And then all I have to do is put those two things together and I get 202. So there you go. When you come to Mathnasium, we spend a lot of time talking about subtraction in this way because it helps a lot in problems like this. And think about when you're practicing and doing your subtraction, and you have to do that over and over and over and over and over again, then that gets boring. And hopefully you're finding this stuff fun. And it's because you're smart and you can do these things, but you have to practice. And this is the perfect time to practice. Okay. Make this just a little bit harder. I'm going to give you a moment. Let's see what you got. So on this one, we have to go just a little bit further because this is not, multiple of 100, right? It's got a little bit more than that. But I still want to start at the smaller number and say how far do I have to go to get from that number to the next 100? Okay. So from 98 to 100 is 2. And you can go all the way from 100 to 202 if you want. But if you want to practice this to kind of get to the next multiple, then how far do you have to go to get from 100 to 200? Okay, that's 100 more. Okay, then how far do you have to get to 202? 2 more. Then all I'm left with is just to add these together. 2 plus 100 plus 2 is 104. You got 104. Awesome job. But this is kind of what's going on inside of your brain if you want to do it this way. But the way you get there is by practicing, but you can also get there by writing these things down. And then eventually you write it enough times, and then all of a sudden your brain starts to think that way. Here's another. Okay, so this is a little bit different. 197 up to the next thing in 200, right? So that's 3. Then you want to jump up from 200 to 400. Okay, and then I want to jump up from 400 to 403. That's 3. So hopefully you got 206. There are other ways. Like I said, you can have subtracted 200 first, and then did I subtract too much or not enough? If I subtract 200, that's too much. I really only want to subtract 197, so then I just have to add 3 back in. But remember, there's always going to be multiple ways to do this, and there's going to be multiple ways to do it mentally, and you have to find the way that makes the most sense to you. And you do that by practicing. And you try it one way, and that doesn't make much sense. I don't like that way, and you do it a different way. You try something and see if it works, and maybe it's wrong, and that's okay too. You're kind of experimenting a little bit. Okay. Maybe just a little bit bigger. Okay, this one I have to admit I added in just to make sure that you were paying attention. This one we don't have to get too fancy. If I start with 3005, I have 3 thousands. I need to take away 1,000. That leaves me with 2 thousands. And over here I have 5 ones. I need to take a 1 away. That's 4 ones. So just make sure that when you're looking at a problem, think, okay, maybe we were talking about some other things, but is that the best way? Hopefully you saw this one and you're like, okay, that's not so bad. 3,000 minus 1,000 is 2,000s. 5 minus 1 is 4. And there you go. All right, I wasn't trying to trick you. I just want to make sure that you're with me and paying attention. Okay, now we're back to something that was very similar to what we were doing earlier. Okay, but the numbers are bigger, so let's see what you do. Yeah, change my color. So I hope you got 1006. Let's just talk about this one. So start with 2,997. How far up do you have to go to get from that number to 3,000, which is 3? How far up do you have to go from 3,000 to 4,000? That's 1,000. And how far up do you have to go from 4,000 to 4,003? That's 3 more. So 3 plus 1,000 plus 3 is 1,006. And that's when what I said to you is kind of the way that you would think about it if you did it in your head. See, the numbers are getting bigger, but what you do is exactly the same. I could give you huge numbers, and if they were kind of set up this way, exactly same idea. But what's cool is, we can do things that they don't even really have to be that close. I can take these numbers further apart and still use the exact same thing. I just start at 2,991 and go up 9. So just because these numbers are close, it's just a practice, but they can get further apart. Okay. I threw a couple multiplication problems in there because, we've been doing some multiplication, but I want to do some more. When you look at that, I hope you saw that. If you've been working with me, then I hope you're starting to look at these things and start to see stuff like that. Like 3 times 33 is what? Okay. So that leaves me with 7 times 99. We talked about 99 times 7 yesterday, I believe. But if you just go from left to right, 7 times 3 is 21, and then you have to figure out 21 times 33 in your head. That's a lot more work and a lot more challenging than figuring out 7 times 99 in your head. Yesterday we talked about, well, if I want to multiply something times 99, I just multiply times 100, and I just need to take 1 away, because I only need 99 of them. You get 693. So the answer to the original problem is 693. So now we're taking what we've learned before and we're kind of extending it, but we're still looking for the same things. Okay. So what do you see? I sure hope you see the 99, because they don't always have to be right in order. 9 times 11 is 99. Then you just have to think about 99 times 3 or 3 times 99, whatever way you want to think about it. Well, times 99, 100, times 3 is 300. I need to take a 3 away. I get 297. All right, you guys are doing awesome. I want to talk about percent for just a moment. And one of the Mathnasium Schoolhouse, if you go into the videos, there's an awesome video on percents. But I like to revisit percents with you just because it's always important to revisit it, and you can do it mentally. My question to you is, and if you were on that lesson, maybe you know. If you don't, that's okay. What is the percent sign? What does percent mean when you see that? If you've done anything with percents, you think percents are maybe super hard. They don't have to be. That percent sign, percent means for each 100. So when you see 2%, you should think 2 for each 100. Now my question to you is, how many 100s are in 500? How many 100s do I have? 5. So 2 for each 100 is 2 5 times, and I get 10. Remember that. Okay, when you see percents, think that. For each 100. 2% means 2 for each 100. I have 5 hundreds. Get 10. All right. So 3.5% of 200. So percent means for each 100. So that means 3.5 for each 100. And how many 100s do you have in 200? 2. So it's 3.5 2 times. It's 7. 3.5 doubled. So even when you see fractions in the percents, you can deal with it in the same way, which is cool. Now here's an interesting fact. If this means for each 100, then what do you think that symbol means? You probably have never seen that symbol before, and not a lot of people have. But since you joined me today, I'm going to show you something. What do you think that means? If this means for each 100, any ideas? That actually means for each 1,000. And that's something for you to look up and practice later. And that's something to show somebody else. So that if you see that symbol, instead of thinking for each 100, you would think for each 1,000. And the next time we get together and do a mental math session, we will talk about that. So I'm going to leave it with that today. I hope you found it interesting. Mathnasium Schoolhouse, we're here every day, Monday through Friday at 11 a.m. Pacific. I will be back next Thursday, and if you join me for my Math Magic session I did a couple weeks ago, I have another one planned for you. If you didn't, go check the video archive, have your parent help you find it, and there's a Math Magic trick in there. And I have another one planned for you next week, but we will be back Monday with the lessons. Today's Thursday. They'll be there Friday, and then I'll be back next Thursday. I apologize. So there will be a session tomorrow at 11 a.m. Thanks for all the hard work. I really appreciate you guys showing up and staying with me. See you all later. Bye.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.